Okay, so we are going to today talk about acceleration. Okay? We're going to talk about acceleration, but before we begin, let's have a little trivia contest here. Christmas is a little ways away. Can you remember the name of the Grinch's dog? Can you remember
the Grinch?
Oh, and the correct answer for the Grinch's dog is C. Max is the dog. Max is the dog. Yeah, sorry, if it was 100%, no, Buster was my dog. And I could easily be confused for the Grinch. I get that. But no. Terrible name.
No, for the Grinch's dog.
Oh, okay. My favorite part, when my kids were young, we watched The Grinch every night for about 6 weeks in a row, I think.
Whoa.
And the favorite part for them when they were little was the part where the Grinch is, Max is pulling him down the hill, right? And the sled goes so fast that the dog goes underneath and comes back around. Remember that part?
Yeah.
Whenever I start talking about acceleration, I always think about that because the Grinch actually accelerates faster than the dog. And I'm like, watching the Grinch, I'm like, that's not possible. Because that's what I tend to do in movies. I break down the physics in them, and people don't like it, especially at the theaters. Okay. Let's continue. Oh, that's no good. I just gave you the answer. You can answer now. Acceleration is like velocity. It's a pretty easy one. Should be a average booster here for you. Acceleration is like velocity. Is it a vector or is it a scalar quantity? And it's pretty much a 50-50 guess if you don't know. Sean, are you going to answer?
Oh, yes, I am. Right now,
Excellent. 100%. Good job. It's a vector quantity, right? Acceleration is a vector quantity. Now, if it's a vector quantity, what does that mean? You'll have to select the best answer. It's true. I believe you have to select the best answer. I may be wrong. There may be, I know that some of the possibilities are that there's two possible answers, but we'll go with just one, I think, here. So far, I'm hoping we're getting full 100%. Oh, correct answer is... I was wrong. I led you astray. Sonya's really mad at me. Look at the look on her face. She's shocked.
I don't even know what's going on.
She's shocked. Correct answer is B and C, right and up.
How come it says 0 and half?
Because nobody put B and C. I had 9% of you said C and 9% of you said B, but nobody said B and C. B and C. About 5 minutes ago.
You are but. We're gonna take that. Fucking butt man.
Can you get this one right?
I'm gonna get it.
Oh! Mr. Bennett.
I'm not gonna get it right. I'm gonna get it right.
There's still gonna be people that get it wrong. I guarantee it.
Yeah?
Yeah, guarantee.
Hey.
No, we're good. We're good. Now, does acceleration always mean slowing down? Does deceleration always mean slowing down? That's the fine print, as I like to say.
You're going to sell your soul, bro.
All right, so does deceleration always mean slowing down? Drum roll, please. Correct answer is no. The correct answer is no. Let's just see what the fine print has to say.
put Blackford up there, oh,
You might want to jot this down. You could consider these actually notes. I haven't really sort of said they're notes yet, right? Did you need to write, let's just go back here a little bit. Do you need to write anything down from any of these slides?
Yeah, that increases dog.
I won't be asking that again. Do you need to write down that acceleration is a vector? I hope not. Do you need to write down that it's positive when it's to the right and to the up? I hope not. Do you need to write down that it's negative when it's to the left and up, or left and down? It's not about the mark. I'm not recording these values, you guys. Relax. You guys are so worried about the mark.
I don't get when teachers do such a bad thing that students are worried about it.
Because in the end, I found over the years that people really, really, really do not have perfect understanding of what acceleration is. So I'm going to try to clear that up a little bit today. So acceleration to the left is sometimes called deceleration, but this does not mean that it's slowing down, because if the object is already moving to the left, if it has a velocity that is to the left, like -5, and I give it an acceleration of -2, guess what? It's going to speed up. So negative acceleration doesn't necessarily mean slowing down. Deceleration does not necessarily mean slowing down. I tend to avoid the word deceleration completely. I tend to not talk about deceleration at all. Okay? You might see it in a textbook question, but I try not to use it in class. I use the expression negative acceleration, and negative acceleration doesn't always mean slowing down. Okay? Probably out there in the real world, deceleration tends to mean slowing down, right? But, okay? You won't hear it much from me. Okay. That's an important thing. Acceleration is defined as the time rate of change in velocity. Okay? That's like a technical kind of definition. Alrighty, so what does time rate of change in velocity mean? For there to be acceleration, there has to be a change in the... Okay, Alex is saying for there to be acceleration, there has to be a change in the speed. Agree or disagree? Who agrees? There has to be a change in the speed. You don't agree with yourself? Okay. Who wants to disagree with Alex's former statement that said there has to be a change in the speed? Who wants to disagree with that? Okay, Lloyd, I'm going to pick on you. Why do you disagree? Okay, so if I said there has to be a change in this velocity, then you would agree with him? Is that not what you want to say, Alex? Okay, excellent. That would be right.
That's what I want to say too.
Okay. Here's the way I like to say it. So acceleration is how fast an object's velocity is changing. Just don't write that down yet. Don't write it down. Put your pencil down. Put your pencil down. You can stop. Think about this. How fast an object's velocity is changing. The velocity has to be changing. Does the velocity change fast or does the velocity change slow? You could also say it's how fast is an object's velocity increasing or decreasing, because it could get bigger or it could get smaller. Now write it down.
Okay.
All right, I got some more small print down here. Here it is in maybe another format. It's how fast you get to how fast or slow that you are going. How fast you get to how fast you're going.
Oh, wait.
How fast you get to how fast you are going. Okay? Now, let's talk about, let me just see what's on the next slide here. How fast you get to how fast or slow you're going, right? If I fire a tennis ball at Connor's head, and he catches it, right? Is he going to slow that ball down really fast? Right? It's going to go from really fast, like 100 miles an hour, maybe not, right? To stop pretty quick, right? It's going to have a really big acceleration, right? But if I throw that same tennis ball at 100 miles an hour, say into a pool of water, like throw it straight down. Does it slow down as fast? No, it doesn't, right? It would keep moving. In fact, it would slow down, and then it would eventually sort of come to rest at the bottom, wouldn't it, right? That would be a slow acceleration. Think about a vehicle. What kind of car or vehicle has a really high acceleration? Can go from like stop to fast, really fast. Race cars, Lamborghinis, motorbikes, right? They go from stop to fast, really fast, right? What kind of vehicles go from stop to fast, really slow? What kind of vehicles have slow acceleration? Sean? They go from stop to fast, but it takes them a long time. Pardon me? Your car. It goes fast, your car? No? Because there's a difference, right? What kind of... Do semis go fast? They're always passing me on the highway. But...
They don't accelerate it.
Exactly. If there's me and a semi at a red light, which one is going to get up to 100 kilometers an hour faster? Me. Right? Doesn't matter what I'm driving. I'm going to get up to 100 faster than the semi is, right? Okay? So it's how fast you get to how fast you're going. Okay. Which one of these is the equation for acceleration? Which one of these is the equation for acceleration? Okay, the correct answer is D. Correct answer is D. The formula for acceleration is delta V over delta T. It is change. What does the delta mean? Change. Delta V means change in velocity divided by change in time. In fact, this formula doesn't even exist. This formula doesn't even exist, and neither does that one. Okay? This is the formula, delta V over delta T. Change in velocity over change in time. Let's see what the fine print is. Acceleration is the change in velocity over the change in time. It's how fast, that's the time, how fast the velocity changes. Okay, good? Okay, here's another one. Now, you have this graph on that sheet, right? Yeah. If you want it in length, the sheets are there by the clickers, right? Yeah. In the graph below, the displacement graph is a curved line, meaning that the velocity is decreasing, increasing, or staying the same. It's pretty good. 90% of you said that the velocity is increasing. Correct answer is increasing. How did you tell that the velocity was increasing?
The line is curved.
It's okay. Nick's saying it's curved this way, right? Okay. Let's use the word slope in our answer. I can tell that it's increasing because the slope is. What if I drew it like this? Isn't the slope positive? But so what is the slope doing in the black one? Use increasing or decreasing? Increasing. The slope is increasing, right? Like if I drew a tangent line here, it would be flatter than it would be there, and it would be even steeper there, right? The slope is increasing, which means the velocity is also increasing. The slope is changing. In fact, I'm going to even take that out and say the slope is increasing. Increasing slope means increasing velocity. Since the velocity increases at a constant rate, now you can't tell that from the graph, I'm telling you that. The velocity graph is what kind of line? Is it a flat line? Is it an increasing straight line, or is it a decreasing straight line? And I'll show you what I mean by this, okay? So if the displacement, the square is covering up the answer. If the displacement graph looks like this, then is the velocity time graph, is it flat? Is it increasing straight? Or is it decreasing straight? Which one of those three is the velocity time?
Can you go on to the question?
Since the velocity increases at a constant rate, the velocity graph is a flat line, increasing straight line, or decreasing line as shown below. Which one of those three is it? Go ahead and start. The question is, basically, which one of these three velocity time graphs corresponds to this one? Like if this is the displacement time graph, which velocity time graph would you get?
Oh, that was it?
Yes. Yes, which one matches? Which one matches?
Can you go back?
Yes. Yes, I
Can I
can.
go back?
I don't know. Try. Yay!
No, can I go back?
I don't know, Connor. Try.
Back over to- Yeah.
It's okay to be wrong,
I don't wanna be.
as long as you learn from it. Ooh, correct answer is B. Very good. Correct answer is B. Because the velocity is doing what? Increasing. This is the value of the velocity. The velocity is going up. Now, because it's at a constant rate, it means it's a straight line. Please note the difference between a straight line and a flat line. I get kids all the time talking about lines like this, and they say it's straight. Yeah, it's straight, but it's also flat. This is also straight, but it's not flat. Okay? There's a difference. Okay. Now, what about the acceleration graph that goes with this one? Because we know it's this answer here, acceleration is the slope of the VT graph. I'll say that again. The acceleration is the slope of the VT graph. So yes, we're going to be dealing with slope again. Okay? What's the slope of this line? Positive or negative? Positive. Is it a constant? Is the slope the same throughout?
Yeah.
Yes, which means the acceleration graph is a graph of the slope of the velocity time graph. The slope of this graph is 0.4. This means the acceleration is a constant 0.4, and we call this uniformly accelerated motion. And I'm going to let you jot that down, and then we'll talk some more about that. Okay, let's go back in time a little bit here, okay? Pay attention close, because this is pretty important. The displacement time graph is curved like that, right? We're good with that? I gave you that graph, right? The corresponding velocity time graph of that is a straight line like this. If I take the slope of this line and I calculate the slope, I would get 0.4. And it's 0.4 throughout. Okay, the slope of that graph is 0.4. So what that means is that the acceleration is 0.4. The slope of the VT graph is the acceleration. And when you graph the acceleration, well, then you get a flat line right at what value? 0.4. We call this uniformly accelerated motion. Uniformly accelerated motion. What does uniformly mean?
Same.
The same. Uniformly accelerated motion means that it's speeding up at the same rate the whole time. Okay? Every second, the speed is changing by how much? 0.4. In fact, if I were to make a chart of the velocity, let me just do this maybe. If I were to make a chart of the velocity with the time, if I started at 0, the velocity would be 0. After 1 second, the velocity would be 0.4. After 2 seconds, the velocity would be 0.8. After 3 seconds, it would be 1.2, and so on. Okay? That is that's the values for the velocity. Okay? Okay. Now, this is not always going to be what's happening. Okay? There are times when you're going to get a velocity time graph which has what we call variable acceleration. A variable is something that changes. So variable acceleration is not constant. In other words, it's not always 0.4. Oh, I think I gave away the answer if you were listening. So here's the graph here. Is it not constant, or is it constant, or it could be constant or not? Sure. This velocity time graph is an example of variable acceleration. The acceleration is not constant, or could be constant or not. If it is variable acceleration. Larissa and Sean left. Put the chair down, please. Correct answer is A, not constant. Variable means that it's not constant. It's not the same. Variable means it's changing. Variable means it's changing. You should have that graph as well. Now, what kind of graph is this? Is this a displacement time graph or is this a velocity time graph? Velocity. It is a velocity time graph. I'm going to ask you a question that's not on the clicker. Listen very carefully. Is this object ever moving backwards? Don't blurt out. Think. Yeah. If you've answered that quick, you haven't thought of it. I'll ask the question again. Is this object ever moving backwards? Alex.
Yes, it is.
Yes, it is moving backwards. At what time is it moving backwards?
Between A and B.
Between A and B, between 4 and about 7 seconds? Okay, so Alex says that it is moving backwards between 4 and 7 seconds. Show of hands, who would like to agree with that? Got a few people. Who would like to disagree? I see some people whose hands did not go up. I'll ask again, and I will watch carefully, and I will pick on someone who hasn't put their hand up, so you better pick one.
Right.
Alex says that it is moving backwards between 4 and 7 seconds. How many people agree that it is moving backwards between 4 and 7 seconds?
I never agree with that.
It's less this time. Oh no, these ladies. How many people disagree? Dylan, tell me, why do you disagree?
Because it's not going backwards, it's just slowing down.
Exactly.
Yeah.
I'll say that again for Dylan. Very nice, Dylan. Okay? This is not a displacement time graph. This is a velocity time graph. So what Dylan is saying is, like, let's just pick a point right about there. What's the velocity right there, Dylan? About 3. Is plus 3 moving backwards? No. Plus 3 is not moving backwards. So unfortunately, for Alex and his gang, they are mistaken, okay? I'll give Alex a chance to redeem himself. What is actually happening between A and B, Alex? Just talk about the object. The object is doing what? Slowing down, exactly. You're right about that. It's slowing down. It's going from 4 meters per second to 3 meters per second to 2 meters per second to 1 meter per second. I'm going to ask Larissa and JC together. What's the fastest speed that this object is moving? What's the fastest speed this thing is moving? Larissa? Well, look at it. Try it. What's the fastest speed? What's the biggest speed? Oh. Okay. Nick, what's the fastest speed? Nick, what's the fastest speed? Okay.
Ask Sean.
Ask Sean?
Like 6.
6?
Kilometers an hour.
Where on the graph are we talking? Right here? Okay, you're right. Absolutely right. Right there is the fastest speed. How come? Because it's the highest point. Right? It's the Well, it's the highest point, right? Highest point. Okay. What's the slowest speed? JC? Which is where? At the beginning, right? Okay. What's the speed right here? B. Yeah, around 2, right? Maybe a little bit less than 2. Okay, that's good. Good. Oh, I knew I was going to do this. Well, we'll see who was listening. I hate it when I do that. I give away the answer before I'm supposed to. Jeez, I hate when I do that.
I've done already.
Does this object ever move backwards? Can't believe I messed that up. There's no H. It's yes or no, Lloyd. Luke? Yes or no, Luke? Come on. Okay, now, you guys realize I gave you this answer already, right? You realize that it better be 100%. If it's not 100%, then the only reason for you not knowing it is I wasn't paying attention.
I had popcorn.
Oh.
Who was it?
We'll see later. I will see.
It wasn't.
Not moving backwards.
It said 21.
Notice that the slope of the curve is not always positive, right? The slope of the curve is not always positive. When is the slope negative? Between A and B, the slope is negative, which means it's doing what? Slowing down, right? Between points A and B, the change in velocity is -2. The time is 3 seconds, which gives us an average slope of minus 0.67. It is slowing down at a rate of minus 0.67 between A and B. I don't have the setup, but I'm going to ask you to draw a graph similar in shape, so that same sort of, up and then down and then back up again. I want you to draw a graph with the same shape, but this time the object is moving backwards.
Oh.
I want you to draw a graph with the same shape, but this time it is moving backwards. Okay, and then I want you to show your neighbor. Okay, what does it look like? Who wants to come up and draw? Alex, come on up. I'll give you a chance. Yeah. Alex is going to draw for us what it looks like to go backwards. I'm hoping everyone's got the same, but we'll see. No, I think Alex is going to come up with the right answer here. Is that what you had?
Yeah, I kind of believe that.
Sort of, kind of? How come it goes backwards, Alex?
Because it's negative. Oh, I didn't label it.
How about I just do this for you? How about if I went like this, right? In this region here, is it going backwards? Yes, it is. How come? Because the velocity is negative. That's good. Good. Okay. Now, you might know this already. I don't know. The units for acceleration are meters per second squared. I'm almost done, you guys. Connor, try and focus. The units for acceleration are meters per second squared. Okay, let's just briefly look at that. Notice that the units on acceleration are meters per second squared. Acceleration is the rate of change of velocity, okay, or rate of change of displacement. Don't write this down. Just watch. Pencils down. I'll give you time. Pencils down. Okay. If I take, right, acceleration is delta V over delta T, right? If I take delta V and replace it with a formula, it's what? Delta D over delta T. So in fact, acceleration is delta D over delta T over delta T, right? Which means there's the double time. Using the units, don't write down yet, hold on. Okay? What's the unit for D? Meters. What's the unit for T? Seconds. What's the unit for T? Seconds. Okay, so it's meters, don't write it down yet. Meters per second, Dividing fractions, that's going to be meters per second divided by seconds. When you divide fractions, you do what? Flip it upside down, so it's meters per second times 1 over seconds. When you multiply fractions, you multiply across. Meters times 1 is meters, seconds times seconds is seconds squared. That's where the unit comes from. Now you can write it down if you want. You don't need to write it down, you just need to know that the unit for acceleration is meters per second squared.